Hello students, welcome you all to a new video of Sunanda's tutorial. In this video we will discuss about the enzyme inhibition. It is the part 2 video of enzyme series. So we are studying these chapters for CSIR NET Life Science exam. So at first, what is enzyme inhibition? It is the inhibition of the enzymatic action. Some molecules or inhibitors are there which blocks the activity of enzymes, which stops the enzyme from doing their work or doing their action. So some blockers or inhibitors stop enzymes permanently and some block the enzymatic activity temporarily. Those inhibitors which stops the activity of enzymes permanently are called as irreversible inhibitors. They bind tightly to an enzyme, often making permanent chemical bond. They completely destroy or ruin the enzymatic activity. Example, penicillin and poisons like nerve gas. Reversible inhibitors, these bind loosely to the enzyme and can detach or pop off later on. They only stop the enzymatic activity temporarily. Okay, so there are two types of enzymatic inhibition, reversible and irreversible. Reversible inhibition include competitive inhibition. It happens when any molecule blocks the substrate from binding to an enzyme's active site. Non-competitive include, here it is a type of reversible enzyme inhibition where inhibitor binds to the enzyme substrate complex rather than the single enzyme. And non-competitive inhibition, it is a type of enzyme inhibition where the blocker or inhibitor binds to enzyme any site other than active site. They do not attach to the active site of an enzyme, they attach to the allosteric site, and from there they block the activity of enzyme substrate complex or enzyme. Okay, next, enzyme inhibition. So at first, competitive inhibition. This type of inhibitor looks just like enzyme's normal target or normal substrate. It resists the substrate to grab the main active site. They compete with the enzyme's substrate for the active site of an enzyme. If you add a lot of real substrate, it can outcompete and push the inhibitor out. So we can overcome this type of inhibition by adding more substrates with to that system. Okay, and the famous example of this competitive inhibition is malonic acid blocks the succinate dehydrogenase during Krebs cycle of respiration process. Okay. Next one is non-competitive inhibition. Non-competitive inhibition, here the inhibitor binds to completely different spot on the enzyme, or it can be called as allosteric site. It changes the shape of an enzyme so that it can no longer do its job, or it can no longer bind with the real substrate. Adding more substrates does not help because the machine itself is broken. And on competitive inhibition, here inhibitor waits till the enzyme at the substrate have already locked together, because this type of inhibitor binds to the enzyme substrate complex. It binds to the enzyme substrate complex and traps them so they cannot finish the reaction or form the product. Now, what is allosteric inhibition and allosteric activation? Allosteric inhibition, an inhibitor binds to any site other than active site, which is called as allosteric site, where they inhibit the enzymatic activity. And what is allosteric activation? Here, An inhibitor binds at the allosteric site and they enhance the activity of an enzyme. That is called as allosteric activation. Okay, so they can be of two types. Either they can act as inhibitor or they can act as activator. Okay, then what is feedback inhibition? Feedback inhibition, where the product of a reaction itself blocks the reactant or the pathway. Okay, excess formation of product blocks the pathway or blocks the reactant to react and form that product or manufacture those products, because the body or cell do not want that product anymore. Okay, now we will discuss what are the effect of those inhibition on Km and Vmax. Okay, so during competitive inhibition the Km increases. Okay, Km increases because the binding of active site with the inhibitor ultimately lowers the affinity of an enzyme for substrate. So ultimately Km increases. But Vmax remains unchanged. Okay. During non-competitive inhibition, the Vmax ultimately decreases because the binding of inhibitor in allosteric site ultimately decreases the activity of an enzyme. So ultimately the Vmax is decreased and Km remains unchanged. And during non-competitive inhibition, both Km and Vmax decreases because inhibitors bind only to enzyme substrate complex. This binding lowers the maximum reaction velocity ultimately and increases apparent substrate affinity. That's why the Km value is decreased. Okay. So these are the effect of inhibition on Km and Vmax value. Okay.